Okay, guys. So now that we have done the 7.3 lab data collection, hopefully we have our observations written down in our data table, and now we're ready to start with the analysis. Okay, so let's look at our analysis slide here. So this is it gets kind of confusing. So we're gonna have to take a step back to what we learned last semester in order to complete the analysis. So first thing it says, write the reactants of each precipitate reaction. Okay, so we're going to start there. Now, to do that, it says use the chemical formulas, or to find that, use the previous slide to get the chemical formulas. Okay, so when we go back to our last slide, it has all 6 of our reactants laid out. So what it says is, we can see it says, okay, in the first test tube, it'll contain a solution of sodium chloride, NaCl, and then we're going to add 3 drops of silver nitrate, AgNO3. So when it says, when we write a chemical equation, we know how to do this, right? So all you're doing is you're saying, okay, for number 1, I'm taking NaCl, and I'm going to add silver nitrate to it, NO3. Okay, and that's our reactants for that equation. Okay, and so what we're going to be doing next is we are going to be predicting the products of that. So go ahead and pause the video, look at each one of these, and set up each one of these equations. Okay. Okay, so now before we move on to the next step, which tells us we need to complete the chemical equation and balance it, we got to figure out, okay, well, what are we doing? How do we do that? Okay, and this is kind of a 2-step process. So what I want to do is let's go back a step and look at, how do we write a chemical formula. So if you look in your notes, some of the things that we're going to need is 4 steps to writing a chemical formula. We're going to need our oxidation number chart, and we're going to need our polyatomic ion list, because we're going to need oxidation numbers for those as well. Okay, so go ahead and pause the video, find that real quick. So once we find that, let's look at some examples here. Turn the camera a little. So say I wanted to bond magnesium, all right, Mg, with fluorine. Okay, we did this a ton in our last chapter. So if we found our steps, we'd say, okay, our first step is writing the elements side by side. So we can say I got magnesium, fluorine, already done. Step 2 is, let's find the oxidation numbers of each. So from there, we can use our oxidation number chart that we have in our notes, which will tell us, or we can say, hey, magnesium's in group 2, meaning it wants to lose 2 electrons, which means it's going to form a positive 2 ion, or have a +2 oxidation number. Okay. Fluorine, on the other hand, is way over in group 7, wants to just gain 1 more electron, and that's going to give it a -1 charge, okay, or a -1 oxidation number. From there, crisscross applesauce, your guys' favorite, we end up with Mg, I don't need to write ones, F2, right? Okay. And so when we write the formulas for our products to this equation, we're going to follow those same steps, but we'll get there. So let's look at one with the polyatomic ion. So say I wanted to bond Be with something like a nitrate polyatomic. So remember, our rules with polyatomics is anything in the parentheses, we don't change it. We don't change the subscript. We treat it just like a normal element, but there's just multiple. That's why it's a polyatomic. Okay. So we follow the same steps. So we say, okay, Be, it's in group 2. It's going to have a +2 charge. Okay. NO3, if we look at our polyatomic ion list, we should see a little negative symbol there, which means it's a -1. Okay. So then we just follow the same steps. Crisscross, don't need to write ones, but I do need to put my 2. So you end up with BeNO3 2. Okay, so now that is no different than what we're doing over here. Okay, so with our double displacement reaction, we now know we're going to take element A, sodium, and we are going to bond it with element D. How do we know that? Remember our generic equation we said ends up as AD plus CB. Okay, so we follow those same steps. So we say, okay, I'm going to write these side by side. Na, NO3. Okay, then I write my oxidation numbers. Sodium is in group 1, meaning it wants to lose one, making it a +1 ion or a +1 oxidation number. NO3 we just found over here, right? -1, okay? Crisscross, we don't need to write ones, okay? So we're good on that one, okay? Now, this is where things get a little bit tricky, okay? So Ag, we're gonna do the same thing here. We know we want Ag and we want Cl now. How do we know the oxidation number of Ag? It's a transition metal. We don't have our Roman numerals, but could we use clues? Okay, so we already know NO3 has a -1 oxidation number, so we can imply that there is a 1 there. We could also say, okay, well, that must mean that there's a 1 there because there's no other subscripts. Okay, so if we uncrisscrossed, we could then figure out that Ag, or silver, is a +1 ion, okay? Or +1 oxidation number. So then we can do the same thing over here. Crisscross, we don't need to rewrite those ones down below. So we end up with then NaCl plus AgNO3 is going to give us NaNO3 and AgCl. Okay. Now the last step is we just need to balance this equation. Okay. So we look through. Na, I have 1, 1. Ag, 1, 1. Cl, 1, 1. And nitrates, 1 and 1. Okay. So we're already balanced. So that one's good to go. Okay. So what I want you to do is pause the video, try and do the number 2. Okay. Don't move on yet. I'll write it up on the board. We'll walk through it again real quick. That way you don't do a bunch of them and hopefully don't have them incorrect. Okay. So pause the video. Try the second one on your own. Okay, here we go. So I'm going to move through this one a little bit quicker. Okay, we're going to do the same thing. So we have BaCl2, so barium chloride, plus Na2SO4, sodium sulfate. So first thing we need to do is we need to write our elements in the correct order, get them side by side. So we need Ba and SO4. So I'm going to write that here. Okay, and then I need Cb or Na and Cl. Okay, next step, just like we did before, let's find our oxidation numbers. Well, sodium I know is a +1 because it's in group 1. SO4, I could look at my polyatomic ion chart, or I could say, hey, this 2 got here because if we uncrisscross, means it's a -2. Same thing here with chlorine. Okay, that 2 got there because that is a +2 for barium. Or we could look on the periodic table, say, hey, it's in group 2. Same thing with chlorine. We want to gain 1, right? On crisscrossing there. And now we have the oxidation numbers of each of these. So we can just transfer them over to this side. Okay. Now that we have our oxidation numbers on our product side, we can crisscross. Now remember, our fourth and final step to writing a chemical formula is reduce if necessary. So if I crisscross these, I'd end up with Ba2SO42, right? That is still a 1-to-1 ratio, so we can reduce that. So we just end up with BaSO4. Same thing here. We don't need to write our 1s down there, so we have NaCl. Okay, so now let's kind of clear some of these out of here. And let's talk about balancing this thing, okay? Because this one we will actually have to balance, okay? So again, with balancing, start with your metals. If you have a polyatomic on your reactant side and it stays together on your product side, treat it as one thing. Save hydrogen and oxygen for last. It doesn't really apply too much here. So let's just start with Ba, our first metal. I have 1 here, 1 here. That's good. Start with Cl, or then go to Na. Na, I have 2 here, only 1 there, so we're going to put a 2. So now I have 2 sodiums, 2 sodiums. Move to SO4, got 1 SO4, 1 SO4, and finally 2 chlorines. Oh, look at that, magic, I got 2 chlorines, okay? So the big key to this, guys, is go slow, trust the process, okay? Write your elements or your components side by side, find the correct oxidation number, crisscross, and then balance, right? We can't balance it before we get the appropriate subscripts, or else we're going to be all goofed up, okay? So that's going to take you through the analysis section. And then if you can do the analysis section, the synthesis questions are very easy because we have zinc, which is our single displacement reaction up here. Zinc is going to be displacing hydrogen. And then here we have Na, or sodium, taking the place of hydrogen here. And so we're going to flip-flop it, see if we can predict our products and balance it if necessary. Okay. Let me know if you have any questions.